Hello, welcome everyone. My name's Jessica. I know nothing about blockchains, so I'm really just here as your MC. We have three excellent presenters who are going to walk us through building what I'm guessing for many of us is going to be our first blockchain network. In case you missed the memo at the beginning, it's useful in this session if you either have a laptop or can peer over a friend's shoulder. Okay, so I'm now going to hand you over to our presenters, Kaia, Sally, Madeline. I'm sorry, it won't stick. Take it away.
Okay. Hello. So we thought there might be 20 people in this workshop, so this is going to be interesting, to say the least. We're very, very happy to see how many people there are, but it'll be interesting. And kind of on that note, before we even get started, I'd love to know just from a show of hands what level of understanding and complexity we are working from today. So if you know nothing about blockchain and you're just like, blocky whatty, put up your hand. Great. If you know a little bit about blockchain, put up your hand. If you're a blockchain expert, put up your hand. Oh, no one can say they're an expert, that's unfair. If you know quite a bit about blockchain or work in that space, put up your hand. Okay, cool. All right, so that's good. Does anyone want to give us a crack at a blockchain definition before we get started? It's really fun.
Is it a chain of blocks?
It is not, despite what many believe. Anyone? Distributed ledger, yep, true. Without a central authority? Yeah, so no middlemen, basically. Yeah, so the first sort of use case was Bitcoin, as a lot of us know, so this idea of decentralizing and distributing sort of processing power. So instead of one like singular centralized processing entity doing all your transactions and charging you for it and taking time and sort of having their own agenda. And again, this is an ideology as well sometimes, so it's an interesting thing to talk about, that like the ideology and the agenda side of things versus the technology side of things. But from a tech point of view, let's get transactions that are faster, are processed by a whole bunch of computers instead of just one central authority, and are securely stored in a very transparent way. So that's the immutable ledger buzzword that we've all heard of. Things are stored permanently on the blockchain forever, can't be changed, and that is the way that those computers hold each other accountable instead of having one central authority that we trust to give us the right sort of outcome or process our transactions. So then that carries over to a lot of different use cases, not just for transactions related to money. So we work for Pegasus, which is I'll do this, yep. So Pegasus is an arm of a venture production studio called Consensus, and Ethereum, which is the public blockchain, had a couple of co-founders. One of them, Joseph Lubin, co-founded Ethereum and then founded Consensus. And essentially, its main purpose is to create projects and sort of stimulate the ecosystem of projects being built on Ethereum. Pegasus is the protocol engineering team. I am a product manager on that team. So I work with the team of engineers that does consensus protocols, consensus algorithms. So has anyone heard of proof of work? Yeah, so just the way that transactions are processed. And you can do that in a couple different ways. We'll get into that in a bit. Madeline Murray, the amazing, as we call her at work. She's a technical writer, but all-around overlord of everything. She's always on top of everything, always the person to go to. And Sally, similar kind of thing. So technically, I think her, protocol engineer, but also all-around superstar legend. Both work on the team of engineers at Pegasus. So that is the briefest of introductions. We're just here because we love blockchain, and because we want everyone else to love it, and we need lots more women and just diversity in this realm, but also just people in general. We'll take anyone. It's pretty new. So again, when we thought there would be like maybe 20 people, we're like, oh, we'll go one by one and you can tell us your name, why you're here. But maybe it'd be great to take a couple minutes to do that within your table, even though the tables are huge. Maybe just quickly, we'll give you 5 minutes, quickly go around the table, say what your name is, maybe why you're here, and what you want to get out of this workshop, and maybe we'll take a couple samplings from these tables, but you get to know each other. Sound good? Okay, go ahead, 5 minutes. Okay. Sorry if we didn't get to everybody. Hello. Okay, let's get started. Okay, so maybe let's go one per table really quick. If there are any general themes that emerge about why you're here, and maybe not what your name is, because probably no general themes there, and what would make this a win for you, maybe let's lead with those, a bold person at each table, starting with this table. Why are you here, and what would be a win for you? Your table. I am.
Well, we've got BHP and we've got Monash Uni, so we've got very different groups.
Oh.
So these Monash students would like to learn more about blockchain and unique blockchain. And BHP are a sponsor for today as well. So they came along because they heard blockchain is cool. So.
Cool, thank you. Karen, by the way, co-organizes Women in Blockchain Melbourne, and she's pretty awesome. Probably won't do every table, actually. Now this middle table. Why are you here? What would you like to learn?
Yeah, we were talking about just getting started, and we'd like to understand it more. So more from that aspect. I don't know, what did you like to talk about? Far away.
It's pretty big. Just getting started? Yeah, cool. And this table back here, last one. Any emerging themes?
Yeah, nothing really. I think it's the same story as the rest. We are the beginners. We'd like to know more about the technology, and we are a mix of national, international, business, industry, QUT. So majority of us from QUT, but then we have got PhD, Texas. That's a member.
Cool. Yeah, I mean, it's really encouraging for us to see so many people here because I think getting started is always the hardest part. And when something is shrouded in mysticism the way that blockchain has and continues to be, it's really kind of scary to even admit that like there are things that you don't know, and that happens at every level. You can never know enough. And so just to set sort of the tone, there are no stupid questions ever, even if your question is, blockchain, who be whatty? Because that means that we haven't explained it well enough. And if we do use terms and things pop up that are just a little bit outside of the realm of your understanding, that's totally fine. Just raise your hand. Or if it seems like there's a lot of pure wisdom in this group, so feel free to leverage that as well. If somebody does know, feel free to educate everyone else. Like that's what this is all about, collaboration. So today, you will, hopefully, download a blockchain client and get it started. So the one we'll be using is called Pantheon. It is coded in Java, so we will be using that one because that's the one that we at Pegasus work on. So essentially just the command line that you're interfacing with the Ethereum blockchain on is how we'll characterize it to start. And then you'll also be what we call spinning up a blockchain network. So essentially just getting your own network up and running where you will have a node and you will be a node in that network. And we're going to be using a proof of authority consensus mechanism. So we talked a bit about proof of work, which is the idea that a bunch of computers essentially race to solve a puzzle, and whoever solves that puzzle first gets to process the transaction. That works great for sort of what we call mainnet. So we're a little bit more enterprise focused, so smaller groups of people who don't necessarily need to have all of the computers racing to solve a puzzle because it takes a lot of time, energy, et cetera. So a quicker way that we like to process transactions in the networks that we're working on is a proof of authority. So each validator node in a network gets a turn. And if you want to learn more about that, there's lots of cool IBFT 2.0 literature that I can direct you to. But I'm just afraid of going down too many rabbit holes of being like, and now IBFT2, a history. And then finally, you will deploy a smart contract. So just a basic contract where you will do something as a member of this network you will be part of. And that is the simplest way that I will explain it. Okay, so to get started, please go to this website. We will now hook up our computers so that Madeline can take you through a step-by-step. Once you get to pegasus.tech/solutions, you should see a page that shows a list of download options. So the latest version is 1.1.4, I believe. Oh no.
Will my,
Oh, something happened, but then it stopped happening.
sorry, so if you scroll down on that page, you should find a, here it comes. Okay, great. Someone did something magic. Oh, a microphone. Hang on. So if you start from pegasus.tech,
You
go,
go here.
I go here? Okay.
Yeah.
Kai's going to drive. Okay.
So scroll down.
Scroll down and you'll see the documentation link up, Kaia down.
Here.
There.
Okay, so we're clicking on a documentation link.
Did everyone find the documentation link? Yep. So down the left-hand side of documentation, you'll see installation. And if you expand that, Kaia, left, underneath Pantheon,
Installation.
and install binary distribution. So I'm pretty sure I see a mix of Windows and Macs out there. So both instructions are on the same page. You've got Mac at the top and then Windows down below. So I'll give everyone a minute to do that.
So the original URL is pegasus.tech/solutions. So Pegasus is spelled P-E-G-A-S-Y-S. .tech. Yep.
Which release?
So just the latest release at the top. Yep, just the latest release at the top. Madeline, did people need to download that before they go to documentation? No, okay. So Madeline's going to come around. If you need a hand, just raise your hand and someone will come around and help you.
Okay, yeah.
Yeah.
So Sally will keep coming around and helping people. Have people on Macs managed to run brew install?
Maybe?
No? So I will demonstrate.
Yes.
Could you increase the screen?
Yes.
Yes.
Zoom in.
Yeah.
Does that increase it?
Is that better? Yes? Okay, so Sally's coming around.
So
Okay.
now I need to increase this in
Okay,
size.
so what if they haven't downloaded Pantheon though?
Well, I'm going to, with Mac, you just do it from the terminal.
Okay.
I'm just trying to, how do I increase
All right,
here?
so
Bigger?
maybe explain it as you're doing it. So open terminal.
Oh no, how do I make my terminal? There we go. Just trying to make that bigger. So, for anyone who's on a Mac, I'm just going to demonstrate doing it. So on a Mac, it's just brew.
Yeah, step one, go into terminal.
Yeah. Sorry, Kaia.
So step one, on a Mac you should have a terminal. So if you haven't opened that yet, go to your search bar, type in terminal. It'll open this program. And then you're essentially just typing in what the text says under install using Homebrew. You can copy paste if you want into terminal and then press enter.
So after you hit enter there, so someone's just pointed out the Homebrew update might take a while because of the Wi-Fi and us all on it. So that's something we didn't see coming or we didn't think about when we practiced this. So I guess if you've got a hotspot that you can go onto, that may speed that along. Oh, mine is going now. I'm on the Wi-Fi, so it did go through eventually. So just given the number of people we've got, Sally will keep helping out with trying to get it installed, but I might demonstrate getting started with the tutorial, and then if people haven't been able to install, they can watch, and then afterwards we can help. We've also got, so afterwards if you go home and you want to try this and you couldn't install, we've got a public Gitter page. You can get in touch with us, we can step you through it. If you're having trouble installing, we can point out other ways to do it. So if you can't do it today and you still want to do it when you go home, at the end we'll flash up some contact options and we can help you with that. So for people who have managed to install, the next place to go is back in the documentation so down in the left-hand menu we've got tutorials. So if you go to create a private network using IFBT2, so the first thing you'll need is, you probably don't need to create four nodes, like probably 2 nodes will be enough to demonstrate that you can get them talking to each other. So basically what you need to do first is set up a folder structure. So like with a blockchain, because we're creating a local network, we'll have 2 nodes on the same machine. In reality, you'd have 2 nodes in different places. That's what creates the blockchain network. But for playing around with it and development, being able to run your own local blockchain is really helpful because then it's under your control, it runs quickly. So the public Ethereum, you can also use Pantheon to connect to the public Ethereum mainnet. But you need Ether to be able to do anything on the public Ethereum mainnet, so that's not great for development, and also it's a lot slower to get synced to the Ethereum mainnet. It takes quite a while because there's 235 gigabyte of data on it. So for development and playing around, having your own blockchain network set up is a really good place to start. So I'm just going to create some folders. Increase it more? Yep. Is that big enough for everybody? Yep. Yeah, so you basically want a top level folder with 2 subfolders called Node 1 and Node 2, and inside each one you want something called data. So it's the tree structure. And I'll give people a bit of time to do that. So the bit we're going to do next is, basically when you create a blockchain, you've got what's called a genesis file, and the genesis file defines the genesis block. So that's the very first block of a blockchain. And because a blockchain builds, so you start with a block, you append to blockchains, that's how they grow. You make transactions, they go into the next block. You make transactions, they go into the next block. So the genesis block is the very first block of a blockchain. So for any network, the genesis block has to be exactly the same for every node on it. So if you join the Ethereum mainnet, the genesis block for that is built into the client. But for any sort of like consortium network or network shared amongst, or consortium network might be, say you've got 10 banks who have got a blockchain between them, they would all have exactly the same genesis file. Each node would have to be referencing that genesis file. So this creates what's called a configuration file, and we've got a tool that then turns that into a genesis file. So what you want to do is, inside your IFBT network, you'll need to go to this page on the documentation, let us know if you need to find it, and copy and paste this text into a file called ifbtconfigfile.json. And there's copy-paste button. All of our documentation's got a button here that you can use to paste it in. Hang on, I'll just... Not sure how to increase my text size on my text pad, sorry, but right down the bottom, there's a line that says count equals 4. Just change that to 2 because we're only generating 2 nodes. I can actually show you on this one. It's this one here. So basically this file defines some things about a blockchain. So there's a thing called the chain ID. So that identifies the chain you're on. So again, if you're on the Ethereum mainnet, so the Ethereum mainnet has an ID of 1, and then there's some public test nets that have got defined IDs. So if you've got your own blockchain network, you can use whatever ID you want to identify it. This next milestone here, it defines, this is quite a bit of detail, which I probably won't go into, but basically the Ethereum protocol changes over time. So it defines which version of the Ethereum protocol you're using. So that's the latest version. And then before we talked about blocks being added to the blockchain, with IFBT2 you define how often they're added. So this consensus protocol, it'll generate a block every 2 seconds. The epoch length, I probably won't go into that right now. It's a thing to do with IFBT2 if you want to read up about IFBT2 afterwards. And down here are some things that are common to lots of blockchains. This one here is important though. So these basically, these are pre-funded accounts. Because it's our own private blockchain, we can, like the money, the ether is meaningless, so we can predefine some accounts that have got ether in them for playing around. So on the mainnet, there's some predefined contracts and stuff, and that will be in the Genesis file. And this one here defines, how many nodes I've got. So this is the one where I've said to change it to 2. So have some people been able to create that file? Sorry, I don't know how loud I'm talking. So in the, once you've got the config file, you can copy and paste in step 3. If you copy and paste this command, so you'll need to enter the path wherever you installed Pantheon. Actually, if you installed Pantheon using Brew, you can just say Pantheon. You won't have to type an entire path. So if you installed using Brew, you'll just be able to copy and paste and then run the command. Build distributions Pantheon. Nope. That did not work. Hang on. So I've got a problem where haven't got the file in the right place. So So this is the joy of live demos. This command should work. I might come around and see if it has been working for anybody. Hi everybody. So I've had some lovely people here at the front point out that maybe we've gone too far into the details without sort of some of the higher level concepts of what we're doing here. So I might run through some of those and show people, like I can show people a blockchain I've got running and we might have a bit more success with that. Does that sound okay to everybody? Yes? Nodding heads? Okay, great. So I've had a few questions about like what is a node? We keep referring to nodes. Oh, Sally's saying, we can't hear me. Okay, I'll go closer to the microphone. So node basically, so we've been talking about an Ethereum client. Pantheon is an Ethereum client. That's what we've been trying to install, and we haven't been going 100% successfully, but that's okay. So basically, when you've got a blockchain, like I'll go back to the consortium example. Say you've got 10 banks, they're all participating in a blockchain and they want to be able to agree on things without a middleman. So what will happen is they all run a node, basically. And the Ethereum client, Pantheon, is what runs the node. So they'll all have Pantheon running on a server at their bank, and that server will be making blocks and proposing blocks. And then the ledger, like the blockchain itself, everyone has a copy of the blockchain. That's the really fundamental thing about blockchain. There's not a central copy of it somewhere. So everybody has a copy of the blockchain. Each node has a copy. And the consensus algorithm that we talked about before, that's the process by which, so the Ethereum client, Pantheon, it runs the consensus algorithm, and that's the process by which they agree. So basically the consensus algorithm is used so the nodes can agree with each other what the blockchain looks like. So if someone tries to be malicious and go off and do something, the other nodes are like, well, no, we don't agree, but that's what the blockchain looks like. So that's how that works. So once you've got it installed, so I believe it or not, I actually have some working installed blockchains on my laptop. It's not the one I want. Yeah. So what you'll see here is, well, before when we were talking about the Genesis file, so here, so again, with the example of running it all locally on your computer, you kind of don't get it. So in reality, like node 1, node 2 and node 3, they'd be off on different servers. They wouldn't all be together because I can agree with myself. But for the sake of demonstrating and like development, it's often really good to have it locally. So what I can do is change into node 1. Oopsie. So then I can start my blockchain. So if you can follow along with the documentation, like if you want to do it afterwards or you are doing it afterwards, you'll see there's big long command lines. We also support like a config file, so you can save your command line options into a config file. I mean, you can use them over and over again without having to remember your whole command line, which is what I'm doing here. So this will start, yeah, so this is my node, it's running. When it starts, you see a bit of, oops, you'll see some log files. So they say this, it loaded this key. So on Ethereum, all blockchains, so basically nodes are, they have a public and a private key. That's the cryptographic thing that keeps it safe. So private key, you've got your private key, that's how you prove who you are, and then everybody else gets your public key. So that's how your node's identified. So it says there it's loading a node, and here it's got this enode address. So that's my public key, and it's where I'm running. So I'm running on my local machine on port 30303. So that's what that is. So later on, when you start trying to do things and talk to other nodes, you need that information. And then there's some other things here. So JSON RPC HTTP. So we've got a JSON RPC API. So that's basically our user interface when we're using, because it's a command line tool. So I'm just trying to find, I wrote the documentation, so you'd think I would be able to find my way around it. So basically when you're interacting with the node, you've got all these methods. So there's a whole bunch of them. So I don't have them all there. So there's admin methods, you know, these are things. So you talk a lot about peers. So when you're connecting to the Ethereum mainnet, so anyone can connect to the Ethereum mainnet, like I could use Pantheon right now to connect to it, but you basically have to get a copy of the blockchain, and to do that, your blockchain, your node goes out and communicates. It basically goes out, looks for other peers, and then it finds a peer, and then they communicate like, that's what the chain ID is. Are we on the same blockchain? And then you say yes, and then you start downloading blocks. So managing peers is quite an important thing when you're using a blockchain. There's also a whole other bunch of methods. I'll demonstrate using some of these in a minute once I get my other node started up. So that's my node 1. It's doing things, and that's what it's saying here. It's saying I've got no one to talk to, because at the moment my node's in a network by itself. So if I open up another window and I go into my other node, oopsie. Config file. Why is it not finding it? Sorry, I don't know why it's not finding my config file on this one. Because it's not there. Let's start a different one. So I've got logging turned off on this node, which is why there's so much. But you should see in a minute, this one here starts talking to the other node. I've run this blockchain before, so we see this here sequence. So I'm up to block 1800. And then you should see over on this node is now talking to the other one. So it's imported that block. So they're actually two different nodes that are now talking to each other. So then you can use the JSON RPC to sort of have a look at things. So if you go into admin pairs, it's not the right. You can see this says that my node, this is who it's paired with. So it's talking to the other node. So I've got two different nodes running, one on each window. And that is basically a blockchain running. So if you're able to follow through the steps in the tutorial, that's what you get to. You have two nodes. Oh, someone's got one going. Hooray! Someone here has a blockchain going. Round of applause. Yeah, no, I was going to say she does definitely get a t-shirt. So we are getting towards the end of time. So I'm sorry we weren't able to help more of you get it going. There are a lot more people here than we sort of anticipated would be. So we've learnt some lessons about what we could do better for next time. But so you've all been to pegasus.tech. So on there and on our documentation page, you can find something that's called our getter. So getter is our public, you can probably find it from our GitHub too. So all our code's open source. It's an open source project, so you can see all of our code. So if you go into Pantheon, that's what we were trying to play with today. And if you go, there's a link here to Getter. So if any of you go home today and that you want to try and run this, then you can always jump onto Getter, and there's me and Sally and a bunch of other people. We all look on there and we can answer any questions you're having if you're having trouble getting it started. And we also have, I don't know how to get back to our slides now, because Kaia's got some other information. Just unplug it. Does that work, do we think? Yeah. Oh, yeah, yes, it does.
Okay. Well, I promised that would be interesting, and I think it was. So clearly this is not the best way to run a workshop in which everyone gets a running blockchain, and I think because peer wisdom is a thing and you're all a supportive group of people, I'd love to hear some feedback on what is a good way. Is it just that we need a smaller number and we need to be working on computers at like an individual level? Or how would you do this workshop differently? I'd love some feedback. Yes.
At other Mocker events I've been to, they've actually sent it out and said, hey, if you want to attend, download everything beforehand. Because I know that some folks are still waiting for downloads.
Yeah.
So I think that would have been a good one.
That would have been an excellent one. Why is this? Yeah, so So in the future, yeah, even just having it installed and then even maybe having done like a little bit of pre-work would have been great. Was that your feedback as well? Did you have feedback?
I feel my feedback actually, instead of directly going into the technical features, giving an overview of what actually a blockchain, what's the node, how is it linked. Those things would have given a better answer.
Yeah, definitely. Great points. Yeah, I mean, I think, thank you for the learning opportunity. Since we have about 9 more minutes, let's jump into, there's lots of beginners here. Who's got questions about just, yep, all right, cool. So let's do a Q&A about things that we can answer from our sort of perches in this industry. So starting over here, yes.
Okay. So, my understanding is you've got the nodes with different operating systems, and then they connect via a client, and they send information to each other, and every transaction is a block which gets copied across every single operating system, and that creates a chain. But I have 2 questions. 1, how do they connect to each other? Is that through the client? And 2, what is recorded in the blockchain? Is it every transaction that operating system has? Is it just related to the client?
Yeah. So how they connect to each other, Sally's probably got a better explanation for me than this. So basically, when you start it up, you'd say that you have ports basically on your computer. It's the same way the internet works, way down underneath that we never notice going. So basically, you start running, you run Pantheon on your computer, you open a port. You basically say, I'm listening on this port. Other Pantheon nodes, not even Pantheon, other nodes out there, like the Ethereum, all the Ethereum nodes are out there, they're all like advertising on ports. So basically, eventually your computer will start getting packets going, hey, and then they talk to each other and then they confirm, we're on the same blockchain. Yes, we want to talk to each other. Have you got more blocks or have I got more blocks? So what happens is when you first connect to the Ethereum mainnet is you'll need to find lots of pairs and sync up. So what happens is you'll go out and search for pairs, and once you get enough pairs, then you communicate about who's on which block, and then you'll start bringing in blocks and adding them. And in terms of what's stored in the blockchain, yeah, so all transactions, they're basically cryptographic magic. Sandra around here somewhere knows more about the cryptographic magic than us. So basically all the transactions go in there, but we use this thing called hashes. Well, not we. Pantheon uses hashes, which basically takes a lot of information, makes it smaller, so then it's feasible to store them.
And if you come to my session tomorrow.
Oh yeah, and if you come to Sally's session tomorrow, she's going to go into a lot more detail about, it's a lot less hand wavy and a lot more actually what happens about how the client works.
Yes.
Yes.
I know you said there were no stupid questions, but still
There.
after all of that, I don't understand what blockchain is. Is it a way of sharing information? Is it, I still don't know what it is.
So one way of looking at it is it's like a distributed database. So at the moment, when you talk about centralised systems, there's a database somewhere and you all go to that database. So you consider them to be like the point of truth. So you'll go there to get your information. With the blockchain, so I think when I first heard about blockchain, the thing I found really hard to wrap my head around was like, where is the blockchain? The reality is every client that's running a node all has a copy of it, like on your laptop. If you were running an Ethereum node from your laptop, you'd have the whole copy of the blockchain on your laptop. And everybody has it. And then you agree, yeah.
If it doesn't, like if it's just everyone's kind of making this database and kind of like adding to it, how does Bitcoin fit into it? Because I thought there was like, you have to mine for Bitcoin, so like
Yeah.
Bitcoin
So you don't,
exists.
yeah. So you don't have to mine for Bitcoin, but basically in a proof of work system, which is what Bitcoin is, and the current Ethereum mainnet is a proof of work system, miners are the ones that add new blocks. So they have to solve the hard cryptography. So not everyone adds new blocks. Like if I run a Pantheon node and hook up to the Ethereum mainnet, I'm not going to be a miner. Because basically to be a miner requires really specialised hardware. So basically out on the Ethereum mainnet, there'll be a bunch of people running nodes, and then there will be mining nodes. And the mining nodes are the ones that add new blocks. So if I'm just participating in the Ethereum network without being a miner, I basically wait till those new blocks like turn up, and then I put them onto my blockchain with my consensus algorithm. Sally's giving me a look.
Oh yeah, just to drill down a little bit more. So basically mining for Bitcoin happens, the process that we're talking about is when the computers, this network of computers has to agree that something happened. So a transaction has been recorded, but everybody has to look at it and verify that it's the same thing. We're all looking at the same thing. It's going to go through. And so the way that that agreement happens is that these computers are racing to solve a cryptographic puzzle, whichever computer gets there first. So the puzzle is just, it's randomly deployed. So it's essentially like a pre-programmed.
Very hard to solve and very easy to verify.
Yeah, hard to solve, easy to verify, and it's like an algorithm it's running, like it's not like a person is sending out Although like you can see how you would think that, but essentially like it's randomized. You just get a random different puzzle thrown at you. And again, no person is doing this, is your computer doing it. And if you get that first, you then get paid with a certain amount of Bitcoin or any other cryptocurrency that's being used. And so essentially you can make money as a miner, like with that hardware, by mining blocks, having a lot of computing power in this scenario. So you're more likely to solve that puzzle first, and then you're banking up this concept of Bitcoin, which allows you to transact.
And that is partly how the network's secured as well, because basically they incentivize it by the amount of computing power you'd need to take over the network, or you might as well just become a legitimate miner. It's more expensive for you to, that's how it works. So it's more expensive to act as a malicious actor than to do the right thing and be a miner. So many questions.
Apart from the consensus algorithm, what all other precautions do you guys have to take for, prevent hackers from,
Leave it to Sally. How do we keep our notes safe?
Yeah, do you want to maybe repeat the question too?
Yes, please repeat the question. Sorry.
So apart from the consensus algorithm, what all other precautions do, the developer has to take, what does the block take to prevent the hackers from getting?
So one of the main precautions is the fact that the blockchain is immutable. So once a block has been added to the blockchain, you can't go back and change it because each block is connected to the block previous, and there's built into the actual blockchain is verifications that this block is connected to the one before, so you can't go back in time and change things. And the other important thing is that it's distributed, so all of the nodes have the same information, the copy of the same information, so you can't sort of hack into it in the way that you could a centralized storage, because it's distributed, it's everywhere. You'd have to change it everywhere.
But if you can't reverse a transaction, if there is a problem, how can you solve this? If you can't reverse it as the data nodes, you said like it's in a sequence or something.
Yeah, so you can add to the record, so you can change it by appending it.
Like some people
But
legitimately do transactions and it can't be reversed.
No.
So how to handle it?
you can't. If you lose your ether, it's gone.
Yeah.
Yeah.
So just on that line, suppose a server goes down and it is in the middle of its transaction. So how do you guys handle that?
So I guess all clients would sort of handle that differently, but until a block is actually created and appended to the blockchain, it hasn't happened. So if I'm a miner and I haven't finished mining my block and my server goes down, well, too bad. Someone else will create the next block. At the back.
What do you think is the most important application of blockchain? There's a lot, but for you, what do you think is maybe the most impact, or where do you see it going in the future?
So this is like the $1 million question, right, for blockchain. So what's the killer app? What is it? It seems like people are starting with finance, health sort of applications, supply chain, but we're all sort of waiting to see, I guess, what the killer app is, because no one's really sure just yet. Yeah.
Can I ask, so many companies nowadays are building their private chain for their business. Can I ask what the key advantage of the private blockchain compared to traditional centralized management system?
So the advantages we talked about, it's distributed, it's immutable, they're the kind of things. But you're right, for a lot of applications, a regular old database might be a better solution. Yeah. I think we're just about out of time, so we're here. You can find us afterwards. I've got to talk tomorrow. You can ask me questions then.